Hello, my friends, Kevin here. Today, we're diving into a set of questions that many people ask. Questions that go deeper than surface-level curiosity and touch the core of how large language models, LLMs, really work. Some of the most common questions include: 1. Why can't LLMs spell words? 2. Why are LLMs weaker at non-English languages? 3. Why do they struggle with simple arithmetic? And more. So let's begin with the first one. Why can't LLMs spell words? Well, the short answer? Because LLMs don't actually follow spelling rules. They guess what looks right based on token patterns. Here's a deeper explanation. LLMs, like GPT, don't process text one letter at a time. Instead, they process tokens. These are chunks of text such as subwords, full words, or punctuation. For example, the word elephant might be treated as a single token. But if split into individual characters like ELEPHANT, that would be 8 separate tokens. And LLMs aren't trained to operate naturally at that level. So when you ask an LLM to spell a word, it's not really working in a spelling bee kind of way. Unless it's specifically trained to focus on individual letters, it won't perform well. Let's move on to the second question. Why are LLMs weaker at non-English languages? Well, the short answer? 1 dash. Because most LLMs are trained primarily on English data. 2. The tokenizer wasn't optimized well for non-English languages. The quality and quantity of training data in other languages is often much lower. Let's explain that more clearly. The text we give to LLMs is first tokenized, meaning it's split into chunks the model can understand. These chunks can be words, parts of words, or even individual characters. The problem? Tokenizers were mostly trained on English text, so they split non-English sentences into more tokens, less efficiently. Let's take an example. Let's say you write in English, "Hello, how are you?" This might be 5 tokens, but its Korean translation, "안녕하세요, 어떻게 지내세요," could be 15 tokens. That's 3 times more tokens for the same sentence. And models have a fixed number of tokens they can process. So non-English languages get less expressive power per sentence, making the model seem worse at them. The result? Less efficient understanding, more mistakes, sometimes switching to English mid-response. Even languages like Arabic, Hindi, and Chinese suffer from this, depending on the tokenizer used. Well, good news? Modern models are improving this by training on more multilingual data and developing better tokenizers, so expect models to get better at non-English languages over time. All right, question number 3. Why are LLMs bad at simple arithmetic? For example, why does a powerful LLM struggle to correctly answer 123 plus 4, 156 equals? The short answer? Because of how numbers are tokenized, it's messy and inconsistent. Let's look deeper. When an LLM reads a number, it doesn't see it as a whole unit like we do. Instead, it breaks it down into tokens. And here's the problem. Numbers can get split in unpredictable ways depending on the tokenizer for. Example, take the number 1234. Sometimes the tokenizer sees it as 1 token. Other times it splits it into 12 plus 34, or even 1 plus 2 plus 3 plus 4. Worse, it might treat 1,999 completely differently. This inconsistent chunking of digits makes it hard for the model to learn patterns, like how addition or subtraction works. There's even a whole blog post titled, "Integer Tokenization is Insane," where the author systematically shows how irregularly GPT-2 tokenizes numbers. It's not just messy, it's a real obstacle for the model's learning. So to conclude, the model memorizes some basic math facts, like 2 plus 2 equals 4, but struggles with bigger or unfamiliar numbers, and often guesses the result based on token patterns, not actual math logic. Are newer models better? Yes, but only a bit. Some recent models use special numerical embeddings or integrate external math modules to help. But unless LLMs are explicitly trained to do math, they'll still treat numbers like any other piece of text. So let's wrap it up. As we've seen today, LLMs aren't bad at spelling, foreign languages, or arithmetic because they're dumb. They just operate based on tokens, and those tokens sometimes work against tasks that seem simple to us. But here's the cool part. In the next episode, I'll show you a clever trick that can override these limitations. A method that helps you get more accurate answers, even in areas where LLMs usually struggle. Whether you're working with languages, spelling, or numbers, there's a way to guide the model more effectively. So make sure you don't miss it. Thanks for watching. See you in the next one.